Good morning, dear students. Welcome to the lecture. So we finished chapter 3 that day, no? So we will go for chapter 4. So in the other lessons, we did the nomenclature of so many compounds. Now we didn't do anything with aromatic compounds. So now we are going to do the names of a few aromatic compounds. Aromatic compounds means aroma means you know the meaning of the term aroma.
The smell?
Yes. Smell, something with smell. Okay, organic. You know, now we can see everywhere organic. When you go to supermarket, organic food, organic this, organic that. Okay, so it's now aroma means smell. Okay, so aromatic compounds, there are different. This is a different category of compounds. So of which the main one is benzene. Okay, so benzene and its derivatives. Actually, aromatic compounds, not just benzene, but to that extent we are not going. So we will do only benzene and its derivatives. See, look, these all names you need to know. Okay, my dear students. Okay, study these things today itself. So next imtihan will be easy for you. Okay, study today's portion today itself. Okay, so now here first is benzene C6H6. You know the structural formula of benzene, right? You know how it is C6H6?
Yes.
Okay, all of you know this, right? So this is the benzene. So 6 carbon atoms are there. Can you see? 1, 2, 3, 4, 6 carbon atoms and 6 hydrogen atoms. Alternate single and double bond. So this is the structure of benzene. So its molecular formula is C6H6. Okay. So this is benzene. Now in benzene, one H is replaced by CS3 group. Did you see? Did you see? Instead of one hydrogen, it's a benzene. So we write the molecular formula as C6H5CH3. So its common chyme IUPAC name is toluene. Okay, so this toluene is actually the common name. It is accepted as the IUPAC name also. Okay, now it has another name. Can you tell me the other name of other IUPAC name of this compound? This is otherwise called.
Methyl benzene.
Yeah, very good, very good. Okay, methyl benzene. Okay, now, of course, one one hydrogen is replaced by ethyl group. So, what is the name of this one? Tell me. IUPAC name. You tell, please. Come on, ethyl benzene. Now, this is this is very important name. It's called anisole. Anisole, you don't forget, anisole is a common name which is accepted as IUPAC. So it's both common and IUPAC. But it has another IUPAC name. Can you tell me the official IUPAC name? What group is OCS3 group?
Methoxybenzene.
Yes, correct. It's methoxybenzene. Okay, now C6H5NH2. What's the name of this one?
Aminobenzene.
Okay, so we call it as aniline. So don't mix up anisole, aniline. Anisole is benzene ring with OCH3, aniline is benzene ring with NH2. Aniline is otherwise called benzenamine, not aminobenzene. In benzene, E is replaced by benzene is BNZDNE. E is replaced by amine, so benzenamine. Okay, now next one, I don't know whether you studied this in school or not. It's called phenol. Okay, study them now itself, my dear students. If it is CS3, it's called toluene. If it is OCH3, it's called anisole. If it is NH2, aniline, OH, phenol. Then CHO group is what group? CHO.
hydroxide,
CHO.
Aldehyde.
Aldehyde.
Yes, it's aldehyde group. See, this is the one. This one. Okay, so it is so benzene ring with an aldehyde. It's called benzaldehyde. Now, this group is, what is this group? Tell me. Tell what is this group? COH group is what
acidic
group?
acid,
Acid group. Yes. So what could be the name now? Yeah.
benzoic acid,
Yes, it's benzoic acid. Benzene ring. I just put the circle. Circle means it's resonance. Okay. So it's double bond O, OH. Okay, so this is called, what's the name? What did you tell me? Benzoic acid. C6H5Cl. This is a normal name. Can you tell me? Its IUPAC name is chlorobenzene. So what will be the IUPAC name of the next one? Are you here?
bromobenzene,
Benzene.
Benzene, yes. Where is the girl who is always coming? Rahma. She's not here. She didn't come for the lecture. Usually she comes for the lecture and she is answering always. She is upset about the exam. Okay.
maybe we have a test.
Okay. Yeah. Okay. Please study all this now itself. Only these many names are you to memorize. Other things it's okay. So don't forget. Benzene ring with NH2 is what? Tell me. Benzene ring with NH2 is. Tell me. Let me see whether you are listening or not. NH2. What's the name?
Benzenamine.
Yeah, benzenamine, or another name I said. What is that?
Aniline.
Aniline. Yes. Okay. So those names, please go home and revise it. Keep revising these names. Okay. At least next exams you get full mark. Now, I just want to indicate this. These all things. Did you study ortho, meta, para, and all that? Have you studied this?
No, doctor.
You haven't
Oh,
studied. Okay. In school, you haven't studied organic chemistry? No, you studied. No.
we took this doctor in our school.
Yeah, okay. So, but only thing is you forgot. Hmm? Okay,
Yes.
so anyway, look here. This is just X. X is a group. It can be chloro or bromo or whatever. Now, the relative positions. So, if you number it, this is a 1. Okay, so this position, this adjacent position, next position, or we call it as 1, 2. If you number this way, it's 1, 2. If you number this way also, it's 1, 2. So 1, 2 position is called, what's the name? What is it called?
Ortho.
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 Okay, ortho position. Now if it is 1 and 3 position, 1 and 3, it's called, come on, 1 and 3, what's the 1 3 position is called, what's the name? Meta. Okay, and if it is 1 and 4, it's called para. Okay, so don't forget 1 2 ortho, it's given here also. 1 2 ortho, the symbol is small letter O. 1 3 meta, symbol is M. 1 4 para, it is symbol is 4. Is it okay for you? Did you understand?
Yes, doctor.
Okay. So adjacent positions, it's ortho. Alternate positions, it's meta. Opposite positions, it's para. Okay. So now, can you tell me the name of the compound which is written here? Anyone?
O dichloride,
Hmm. O dichloro. But this ortho, meta, para are common names, not IUPAC names. Okay. Look, I just look. See, this is same as writing like this. It's need not be one is the top position. So if I write here also 1, 2. Understand? You understand why I put this ring? Ring means it's just same as alternate, single and double to save time. Okay? Understood?
Yes, doctor.
Yes.
Okay. So it can be any alternate positions. So I just put a circle to save time. So I can put CL here. I can put CL here, CL here. Or I can put, come on, you tell another 2 positions. So it can be CL here, CL here. Or it can be anywhere. You understand the meaning, right? So then the hand don't get confused. So this is 1, 2. So like that. So the name is ortho, small letter O, and after that dichlorobenzene. This is a common name. Okay, so what is its IUPAC name? Can you tell me the IUPAC name? Tell the positions 1, 2 dichlorobenzene. Understand? Understand?
Yes,
Yes.
doctor.
Yes.
Similarly, meta, it can be any alternate positions. Need not be this one. So you want me to do all of them? I'll just do one more. Say CL here, CL here, or like that, anything. Okay. So what is the name of this one? Common name? Tell.
Dichloro.
Yes. M-dichlorobenzene. And this is 1, 3 dichlorobenzene. Now similarly 1, 4. Need not be this one. It can be anything. Okay, say 1 CL here, 1 CL here. So, or anywhere. So it's P, come on, dichlorobenzene, 1, 4 dichlorobenzene. Okay, I just want to do a few more things. Okay, I will write it. You know, benzene ring with OH is called? Benzene ring with OH is called?
Phenol.
Phenol. Okay, suppose we have 1 CL here. Between OH and CL, which one has more preference?
OH.
Yes, OH has more preference than CL. So OH will be the suffix, CL will be the prefix. Okay, now since OH has more preference, you need to start numbering from that. These all rules so many times I said in the class, right? But in the group I saw so many are asking me the question. Okay, yes, what's the name? Come on, tell me. What is the name? This one's common name is metachlorophenol. So once you write it as a derivative of phenol, that carbon containing OH must get 1. So that's very important. Okay. So and this is a common name. And what about the IUPAC name? Can you tell me the IUPAC name? It will be what's the name?
3-chloro.
Yes, 3-chloro, 3-chlorophenol. Understood?
Yes.
Okay. Okay. Suppose we have another one. Yes. What's the name? Sorry. Yeah. Tell please.
3-methoxy. Phenol.
Yes. See, look, the position means it depends on the preference, not on the top position or something. So here you need to start numbering from this side. So it's 1, 2, 3. So the name is meta-methoxy benzene, and IUPAC name is 3-methoxybenzene. Okay, next. What's the name?
Doctor should be phenol, right?
Oh, sorry, my dear. I was sleeping. I was thinking about the next question. Sorry, dear. Thank you so much. Methoxyphenol and 3-methoxyphenol. Yes, tell me please. Next one. Come on.
P.
4-hydroxy.
Yeah.
Phenoamine.
Phenoamine. Here we have NH2 and OH. Which one has more preference?
NH2.
Really?
O.
OH. OH has more preference than NH2. So OH will be the suffix, NH2 will be the prefix. So how do you tell me the name now?
P-aminophenol.
Which amino? Yes. P-aminophenol. It's a common name. IUPAC
4-aminophenol.
Okay. Suppose. Okay. Tell.
P-methyl aniline.
Yes. NH2 has more preference than CH3, right? So the name is P-methyl. P-methyl aniline or benzenamine. Both are correct. Okay. That's a common name. So this is what? 4-methyl aniline is the IUPAC name. And one more IUPAC name is there. That is 4-methyl benzenamine. Benzenamine is not common, okay? It's IUPAC. Benzene. Spelling is wrong. Benzene, then amine. Okay, so I hope you understood the things, right? Clear, no? Ortho, meta, para?
Clear.
The only problem is these names, if you know this page, everything is done. If you know this page, it will be easy. Okay? Okay, I'll do one more question. There is no slide, I think so. Okay, I will do one question. Can you tell me?
O-hydroxy benzene.
Okay. O-hydroxy. O-hydroxy.
Benzene aldehyde.
Aldehyde? Is it
No,
aldehyde?
benzoic acid, sorry.
Okay. IUPAC.
2-hydroxy.
Yes. Girls all are sleeping. 2-hydroxybenzoic acid. Okay, so like that I can, if it is with something with benzaldehyde you want me to give. Okay, there's no place there, so I'll write some. Okay, can you tell me? All right, properly. Okay. Yes, CHOOH. Yes, tell me.
Oh, hydroxy benzaldehyde.
Yes, orthohydroxybenzaldehyde. Okay. And what's the IUPAC?
2-hydroxy benzaldehyde.
Yes, 2-hydroxybenzaldehyde. Okay. Okay. So the names are fine, I think so. Now, this is benzene. Okay. Okay. So here, you know the resonance. You know the meaning of the term resonance. Actually, here look. The position of the double bonds in this case, double bond here, then double bond here, alternate, conjugated. You know, conjugated means alternate, okay? So we have alternate double bonds and single bonds. Now you can switch the position. So here it's double bond in this case, single, double, single. But here you switched it. This side it was single, this is shifted to, this bond is shifted to that side, so it became double. So the original structure is a hybrid of these two. Okay, so there is no true single bond, there is no true double bond. It's in between that of single and double. So instead of drawing like this, you can put a circle there. So this is a resonance hybrid. These two structures are called contributing structures, or I will write it. So they are the resonance structures or contributing structures, or there is another term, canonical structures. Okay, so now how do you know it is a resonance hybrid of these two? Look, just a minute. Okay. See, look. If this is the correct structure, or this is the correct structure, we have CC single bond and we have CC double bond, right?
Yes.
Okay. If it is like this, you know, before at the beginning I told you double bonds are shorter or longer than single bonds. Tell me. Double bonds are shorter. So you should get two values for bond length. One for this double bond, which is shorter one for this single bond, longer one. But actually, see, you are supposed to get two values. CC single bond value is 154 picometer and CC double bond value is 133 picometer. So you are supposed to get 154 and 133 as we have single and double. But experimentally, if you find out the values, you can see that Camel same bond length, and what is the length? 139. Did you understand what I'm telling? So everywhere the same bond length there is. So if it exists like this, you should get two values. But actually you will not get two values. You get only one value. That value is in between that of single and double. So which shows that in the original, in the correct structure of benzene, there is no true double bond, there is no true single bond. It is in between that of single and double. Is it okay? Did you understand what I said?
Yes, yes, yes.
Okay. So now, next is, where is it? Yes. Rest. This is very important topic. When you see a compound, you need to know what type of resonance is possible. Based on this, there are a lot of questions. It's so easy. I will do one for you. Okay. Look, the first, when you see the compound, it's very important to know whether it is what type of resonance. Actually, resonance are of two types. One is plus resonance, the other one is minus resonance. One is plus R, the other one is minus R. Okay, I'll tell you the meaning of plus and minus. See, look here, listen. I have chlorobenzene. Just imagine. Okay, did you understand what I did? Please, you respond. Nobody is here?
Doctor,
Okay.
can you repeat?
See, resonance are of two types. One is called plus R, the other one is called minus R. I'm going to explain the difference between plus R and minus R with an example. So I just did chlorobenzene. Is it okay?
Yes.
Yeah, okay.
Okay, so now the most important thing is how many lone pairs are there on atom which is attached to benzene ring. This is very important. That decides whether it is plus resonance or minus resonance. Now the one I'm going to tell is very important because in the imtahan I will not give you the specific one. I can give any question. When you see a question, you need to realize whether it is plus R or minus R. So you need to understand it very well. Now, Cl is from which group of the periodic table? Cl group
17.
17. So it has 7 valence electrons. Correct? Correct? So of those
Yes.
7 valence electrons, it used already 1 electron for forming bond with the carbon atom of benzene ring. So it already used 1 electron for forming bond with this carbon. This is carbon's electron, this is this one. Now how many electrons are left on chlorine? 2, 4, 6. This is the most important part. Did you understand what I did?
Yes.
Okay, so now look, another one I will do. OH. O, which group? O is from which group?
16.
16 group. How many valence electrons?
6.
6. How many electrons are used up already?
2.
2. How many electrons left on oxygen?
4.
4. So if you know this much, then it is done. Okay, then it's done. Oh, understood what I did. Now, how to draw the resonance structure? Okay, listen, my dear students. If one atom has a lone pair or a positive charge or a negative charge, and second atom, the next atom has a double bond or a lone pair or a positive charge, they are in resonance. We call it, they are in conjugation. Look, what happens is the beginning part little difficult for you. These two electrons will form a bond here. So when it forms a bond, their valency of carbon will not be satisfied. So these two electrons will shift to the next carbon. So what happens is, see, you have benzene ring. This bond is here, this bond is here, not affected. Cl. It had 3 lone pairs. Now it will have 2 lone pairs. Since it is losing 1 pair of electrons, we give a positive charge to that. Now, those 2 electrons form a double bond here. Now the other electrons shifted and it became like this. Did you understand something?
No.
Or you want,
Can you repeat?
you want me to show again? See, look here, dears. I'm drawing again the same thing, okay? Cl here, 2, 4, 6. Here we have bond this side, we have bond this side, this side. Is it okay? What I did? What I did, you understood. Look, for resonance to occur, this chlorine has a lone pair. Next atom has a double bond, so there is resonance. Okay, so these two electrons will form a bond here. See, it will form a bond here. These two electrons form a bond here. Cl is the one losing its electron. Cl is the one using both the electrons. So Cl gets a positive charge. Now it forms a bond over here. Already it has 1, 2, 3, 4 bonds. Maximum carbon can form 4 bonds. Already it has 4. If one more double bond is coming there, means it will become 5. So to avoid that, now this bond, one bond means 2 electrons. This bond will become 2 electrons. So basically 2 electrons form a bond, one bond will become 2 electrons. See what will happen. These 2 electrons form a bond here. Sah. So I will do that now. This remains same, this remains same. This Cl here 2, 4, that is forming a bond, right? That forms a bond here. Is it okay? Is it okay? Now Cl is using both the electrons. So Cl gets a positive charge. Now, what will happen? Now, valency of carbon, if I put a double bond, valency of carbon is will not be satisfied. So, what will happen? This bond will shift to the next position. Okay, so that is this bond, this one. This bond will become 2 electrons, right? So, what will happen? Those 2 electrons are here. Is it okay now? Is it okay?
Yes, but why you put positive and negative charge?
My dear, look, one first case in this, see, here we have Cl, here we have a double bond, here this carbon, this carbon. So these 2 electrons are shared, 1 electron from this carbon, 1 electron from this carbon, right? Now both the electrons are going to 1 carbon, so this carbon is getting extra electron. So it's getting negative. If they share, there is no negative positive. But only one in this particular case, this is the one losing its electrons. It's giving the electrons. This one is giving, so it's getting positive. Now this carbon is getting the 2 electrons, extra electron it's coming. So it is getting negative charge. Electrons are negatively charged, no? So if electron is, if an atom is getting electron, it's negative. It will be negatively charged. If an atom is losing electron, it gets positive charge. Okay?
Yes, okay, doctor.
Okay, so now the next structure. What is the next structure? You tell me. Next, this is the first structure and the process will keep on continuing. Now what will happen? Again, same process. These 2 electrons will form a bond here, right? Okay, so what will happen? What will happen? This bond, this bond will become 2 electrons. Same process will take place. See, this is the one. Top part it remains same. 2, 4, and a positive charge. Now, what is the new thing? So this bond already is there. Now, what will happen? Tell me. These 2 electrons are forming a bond here. So you get an extra bond here. Understand? Understand?
Yes.
So now what happened to this bond? This bond became 2 electrons. That 2 electrons will go there. So you get this. Okay now? Okay? What's the next structure then? What is the next structure now? Tell me.
electron will be a bond.
Yeah. So 2 electrons form the bond. This bond will become 2 electrons. Same process. So you get double bond Cl 2 4 plus. Now this bond remains the same. Now the new bond is formed. What's the new bond formed? Here we have a new bond, right? Correct? What about the other one? What about the other thing? You have 2 electrons, right? Honestly, I will sleep now. Nobody is telling anything. So now tell me the next one. Yes, come on.
The 2 electrons will be a
This
bond.
remains same. This remains the same. Now these 2 electrons form a bond, right?
Right.
Right?
Yes.
Right.
Then
No.
this bond will shift back. Okay, so this is forming a bond. So this will become now a single bond. 2, 4 is getting the electron back. So no charge. So you are getting the original one. Can you see? We started with this one. You ended up with the same thing, but the difference is here the bonds are this side. Here, here, here. Now in this case, bonds are there on the other side. Is it clear for you?
Yes.
Okay, so now there is another way to do this. Suppose if you start with this structure, can you see this structure? I can start with that structure also. Both of them are the same. Okay, look here. Suppose whatever you want, you can do it. 2, 4, 6. The bonds I put here. You understand what I meant? I start with this. Sir?
Yes.
So
Right.
tell me the shifting. Tell me the shifting. How will it go?
Be
These
like
2
the
electrons
previous
come
one.
in. Now which side it will go? Right side or left side?
Right.
Right. Why the bond is here? So this will go this way. So what structure you will get? This remains same. This remains same. You get double bond Cl 2 4 plus, and you get negative. You understand? Understand? That means you get the structure. Did you see? Then what will happen? This will form bond. This bond will shift. Okay, you understood? Did you understand what I'm telling?
Yes, doctor.
So you don't have to draw both. Okay, so that means next one you will get this, then you will get this, finally you will get this back. So basically you can just do any way, any of the ways. Okay, so now why is it called plus R? Because the atom which is attached to this benzene ring is having a positive charge. Did you see? Plus R. Is it clear? Is it clear?
Yes.
Now, look at this one, phenol. Will it undergo plus R effect? Will it undergo plus R effect?
No.
Why?
It will gain an electron.
No, dear. Say. OH2,4. The same here. So what will happen? These two will form a bond. This bond will shift. So what do you get here? Tell me. Tell me.
Oh, double
Double bond OH. Wahat lone pair. There is a positive charge. This will go here. This remains same. This remains same. Next one. What is the next one now? Next one now. Come on. Come on.
The electron will switch with
This will form bond, this will go, and it goes. So does it undergo plus R?
Plus R.
Yes, yes, it will undergo plus R. Now look, another example I'll give you. Does this undergo? Does this undergo? Tell me. Plus R. You are not. Oxygen, which group of the Jadwal diary, my dear students?
16. Group 16.
How many valence electrons it has?
6.
6. So how many electrons we used already?
1.
One electron is used for forming bond, this bond. The other electron is used for forming bond, this bond. How many electrons left now?
4.
4. So these two will form a bond, this bond will shift. Sir, understand? Understand?
Yes, doctor.
So it undergoes plus R. Now I just need only 1 or 2 minutes. What about this one? Does it undergo plus R? Nitrogen, which group of the periodic table, my dear students? 15th group. So it has how many valence electrons? Tell me. How many valence electrons it has?
5.
5. How many electrons already used up for forming bonds with other atoms?
3.
3. How many electrons left?
2.
2. So now, will it undergo plus R? If these two electrons form a bond, this shapes means plus R. Did you understand? So what is the condition for an element to show plus R? Tell me the condition, or not element, compound to show plus R. My dear, if there is a lone pair on the atom which is attached to benzene ring, it undergoes plus R. See, it has lone pair, it has lone pair, this one has lone pair, chlorobenzene has lone pair. If there is any lone pair on the atom which is directly attached to benzene ring, it undergoes plus R. Look at this one, benzaldehyde. Okay, benzaldehyde. Carbon is from which group of the Jadwal dowry? Carbon, 14th group. How many valence electrons it has? 4. CHO is C double bond OH. How many electrons are already used up?
4.
4. How many electrons are left on carbon?
0.
So no electrons. So does it undergo plus R?
No.
No, it undergoes minus R. That I will teach you next class. So I hope you understood what plus R is.
Doctor, I have a doubt.
Yes, dear, ask.
What if there are two groups, one has plus R effect, one has negative R effect?
On the where?
No, like on the same benzene ring.
Benzene ring at 2 different places, you mean?
Yeah, one has plus R, one has negative R.
Yeah. There are possibilities, dear. So the effect will go both ways. It can go. So in that case, the properties will be decided by the one which is having major effect.
How do we know which one has the
Same.
major effect?
Yeah, it's there in the portion, my dear. It's there. It is there in the topic which I will teach. Okay? I will teach. It is there in the syllabus. Which is more reactive, benzene or phenol or para hydroxy benzaldehyde. All these things are there. It's there. Maybe after the break we will do all that. Next class, I don't know whether we will reach there. I don't think so. Maybe we will reach next class, or after that we will do that. It's there in the topic. Don't worry. Okay.
Okay, thank you.
Anything else to ask? Anything else? Okay. Okay, please go home and revise it today. At least 10 minutes you study today, 10 minutes study tomorrow also, so that you get full mark for the exam. Okay?
Thank you, doctor.
Okay. No.